Right, number 3, the function f is defined in the closed interval from -5 to 4. The graph of f consists of 3 line segments and is shown in the figure above. Let f be the function defined by g of x is equal to the integral from -3 to x of f of t. Well, this is one of those problems, and I'm going to start out before I even get going. I am going to list what we know. So g of x is equal to the integral, which I know is going to equal the area under the curve. So if I find g prime, that's going to equal f, which is the curve. And then g double prime is going to equal f prime, which will be the slopes of f. So if we write that down, hopefully we don't need to think about that later. So for part A, it says to find g of 3. So I know to find g of 3, it's just going to be the integral from -3 to 3 of f, and I took that right from this part right here. So we just want to find the area under the curve from -3 to +3. So it's going to be this whole triangle plus this little bit of a triangle right there. So for the first triangle, I'm going to get 1/2. The base of that would be 1, 2, 3, 4, 5. And then the height is 1, 2, well, I scribbled it out. I cannot see. Give me a second here. That will be 4. And so that is equal to 10. So that's that first part. And then the second part, since we're going to do 1/2, and it's going to be negative because it's underneath the x-axis, times the base is 1. But if I'm looking for that height, what I am going to do here, since I can't tell for sure, I need to know the slope of that line. So I'm just going to do a quick up here, do the slope of that line. This would be the point 0, 1, 2, 3, 4. So if I find the slope of that line, it's going to be -4 minus 4 over 4 minus 0. So that equals -8 over 4. So that slope is equal to -2. So I know from this point I would go down 2 over 1. So this point is going to be at -2 or at 2. So the height of that is going to be 2. So -1/2 times 1 times 2 is a -1. And if I put those two together, 10 minus 1 will be 9. All right, and that was worth only 1 point, doggone it. All right, part B. On what open intervals contained in -5 to 4 is the graph of g both increasing and concave down? Okay, I know increasing has to do with g prime, and I know concavity has to do with g double prime. So I'm actually going to do both charts for this one. I'll do a g prime chart. And we already know from the last screen that g prime is just equal to f, or it's equal to the curve. So if I'm looking at the curve and looking for where the curve equals 0, it's going to equal 0 at -3 and at 1. So I'll put those numbers. And then that graph is above the x-axis before -3. It's still above between -3 and 1, and then it drops below. So, so far my candidates would be these two areas right here. Then I'm going to look at g double prime. G double prime, we already found out, was equal to f prime, which is the slopes of the curve. So the slopes are negative till I get to -3, and then they are positive till I get to 0, and then they are negative after that. So I need to find out where is g both increasing and concave down. So I notice definitely on this part right here, g prime is positive and g double prime is negative. So that would be from where it starts, which is -5. So first of all, that would be from -5 to -3. And then let's see if there are any other areas. Since this changes to negative at 0, this stays positive till I get to 1. I'm going to say between 0 and, well, actually I'm going to change this. This is supposed to be at 2 not 1. If I look at where that's touching, it's touching at 2. I notice between 0 and 2, g prime is positive and g double prime is negative. So these are my answers, and my reasoning why will be because g prime is positive and g double prime is negative. All right, this problem would be worth 2 points, 1 point for getting both intervals correct, and then 1 point for your correct reasoning. All right, part C, the function h is defined by h of x equals g of x over f of x, find h prime of 3. So it's asking me to find a derivative, and I notice that this is a quotient, so I'm going to be using the quotient rule. So we've got f and g. F prime, the derivative of g of x is just g prime of x. and then g prime, the derivative of 5x is equal to 5. So I'm ready to find the derivative. So h prime of x will equal f prime times g, so g prime of x times 5x, minus f times g prime, so g of x times 5, all over g squared, which will be 25x squared. Don't forget that you have to square the 5 and the x. All right, so now we want to find the derivative at 3. So now I'm just going to plug 3 in for all of my x's. So g prime of 3 times 5 times 3 minus g of 3 times 5 all over 25 times 3 squared. All right, so now when I do this, g prime of 3, g prime, remember, is just the same thing as f. So if I look up f at 3, we already found that we already found that the slope was equal to -2, so I think we already found that that point was equal to -2, so that's going to be -2 times 5 times 3 minus g of 3, I believe we found in part 1 was equal to 9, and then times 5, and then all over 25 times 9. And if I figure that out, this should equal -75 over 225. Now if you left your answer like that, that's totally fine. If you reduced it, that would equal -1/3. So either one of those is an okay answer. This problem was worth 3 points. You got 2 points for correctly finding the derivative of h. So if you did that, if you made one mistake, give yourself 1 out of the 2 points. As long as you use the quotient rule, I'm guessing you should give yourself at least 1 point for that, and then 1 point for the correct answer on that one. If, just a little side note, if you did not get part A right, but used it correctly, so you put the wrong number here, but everything else was right, you could still get all 3 points for this problem. Okay, part D. The function p is defined by p of x equals f of x squared minus x. Find the slope of the line tangent to the graph of p at the point where x equals -1. So if they're asking me for the slope of the tangent line, they're basically just asking me for the derivative again. So I'm going to take the derivative of this. I do see parentheses on this one, so I'm actually going to do a u substitution. I'm going to let the u equal x squared minus x, and du would equal 2x minus 1. So when I'm taking the derivative of this, p prime of x is going to equal f of u, the derivative of f of u would be f prime of u times du, and then, because we have to take the derivative of what's inside, and then if I just simplify that, I'm going to get f prime of x squared minus x times 2x minus 1. Okay, so now we're ready to go. Just like we did in that last problem, we want to find it at the point where x equals -1, so we're going to be putting -1 in for our x's. So p prime of -1 is equal to f prime of -1 squared minus -1 times 2 times -1 minus 1. Okay, so this is going to be equal, -1 squared is 1, 1 plus 1 will be 2. So we want to find f prime of 2 times 2 times -1 was -2 minus 1 is -3. Okay, f prime of -2, we already found out the slope at 2. We found the slope of this line already, and we found that that slope was equal to -2. So my answer is going to be -2 times -3, which is an answer of 6. So that was worth 3 points once again. You got 2 points for correctly finding that derivative, minus 1 point for any errors that you made, and then 1 point for this correct answer.